All right, we've learned how to multiply, divide, and add. So now let's learn how to subtract with scientific notation. Okay, so I'm going to have the problem 8 times 10 to the 8th, and I'm going to subtract 5 times 10 to the 7th. Okay, I immediately notice again that these are not the same powers of 10. Okay, this is a power with an 8. This has power of 7, so I want to switch it so they both have the same powers. So I'm going to change them so that they have powers of 7. So this is going to be 10 to the 7th. This is going to stay the same, so it's still going to be 5 times 10 to the 7th. Okay, so I'm going to change this. So since I'm going down 1 power of 10, since I'm going down 1 power of 10, that means I'm going to move the decimal 1 time to the right, and I'm going to show you over here. So I had 8. Here was the decimal. Because I went from 8 to 7, I'm going to need to move it to the right. So it's going to go right here. I'll insert a 0, and now that number becomes 80. So now I'm going to have 80 times 10 to the 7th. Okay. Again, we're subtracting between those two. We learned in distributive property, basically says where I distribute because these are the same bases of 10 with an exponent of 7. Distributive property says I can then take 80 minus 5, and I can multiply by the power of 10 to the 7th. So I just basically all I'm doing is I'm taking this 10 to the 7th and I'm pulling them down here because they're the same. Okay, so I only need one of them. So now I do 80 minus 5, which gives me 75. So now I have 75 times 10 to the 7th, which I know that scientific notation doesn't allow me to write a number greater than 10. So I need to write a number so that it's less than 10, and that decimal would be right. The decimal currently is right here after the 5, but I need to write it so that I have a number less than 10, so it would move right here is where I need to move it. Okay, when I rewrite that, that number would be 7.5. If I go from this dot to this dot, because I'm going to the right there, I would add 1 to this, so I would end up with an answer of 10 to the 8th. All right, so I'd have 7.5 times 10 to the 8th. Okay. So let's go ahead and look at another one. Let's look at 9 times 10 to the 6th minus 450,000. I know this is a little bit different because this one isn't a power of 10, so the first thing I need to do is I need to change this so that it says a power of 10. So I'm going to change this into a power of 10. So the decimal is right here. It's going to move to right there. So here's the location that it's going to be moving. So my new number is going to be 4.5 times, how far did it move? 1, 2, 3, 4, 5. So I'm going to have 10 to the 5th. So I got the 4.5 times 10 to the 5th because that's what's equal to 450,000. I'm going to go ahead and rewrite this one now. Okay. Now what I need to do, now what I need to go ahead and do is I need to have the same powers of 10. So I'm going to go ahead and change this one to 10 to the 5th power, since this one is already the smaller one. So nothing's going to change on the right here. Since I'm going down 1 unit, it was at 9. I'm going to move that decimal from behind the 9. It's going to move 1 spot to the right, which would make it 90. So I'm going to have 90 times 10 to the 5th. Now I'm going to have 90 minus 4.5 because I'm taking those two factors and I'm grouping those together because the distributive property allows me to do this. Taking the 10 to the 5th and I'm going to write it down here. I'm going to be multiplying, sorry, not subtracting between that. 90 minus 4.5 gives me an answer of 85.5 times 10 to the 5th. Again, I need to move it so that I have a number between 1 and 10 in scientific notation, so I need to move the decimal to there so that I have 8.55. I would move it 1 spot to the right, so I'd have to add 1 here because I'd get 10 to the 6th. So I'd get 8.55 times 10 to the 6th. Good luck with subtraction.